Module 5, DNP3 Functions and Control Operations, Reading, Writing, and Executing Actions. 5.1 Purpose of DNP3 Functions. DNP3 defines a formal function model that governs every interaction between a master and an outstation. Functions specify what action is being requested and how the receiving device must interpret and respond. Unlike generic request mechanisms, DNP3 functions are explicitly enumerated, deterministic in behavior, closely bound to utility operational workflows. Each function is identified by a function code carried within the application layer. 5.2 Function Code Classification. DNP3 function codes fall into several broad categories: data acquisition functions, control and actuation functions, configuration and maintenance functions, time synchronization functions, file and data management functions. Only a subset is required for basic interoperability. Others support advanced automation use cases. 5.3 Data acquisition functions. Read function. The read function is the most frequently used DNP3 operation. It enables the master to retrieve data from an outstation. A read request specifies object group S, object variation S, point index ranges or qualifiers, static data, event data, or both. Read operations are used for event polling, integrity polls, startup synchronization, periodic database refresh. Responses contain one or more object headers followed by encoded object instances. Integrity polls. An integrity poll is a read request for all static data of specified types. Characteristics returns full system state, used sparingly due to higher bandwidth cost, acts as a consistency check between master and outstation databases. Integrity polling is essential after communication outages or device restarts. Number 5.4 Event polling functions. Masters commonly issue read requests targeting Class 1 events, Class 2 events, Class 3 events, any combination of event classes. Event polling minimizes bandwidth usage by returning only changes, not entire datasets. Event buffers in the outstation are cleared only after successful transmission, ensuring no loss of critical data. Number 5.5 Control Operations Overview. DNP3 control functions allow masters to act upon physical processes through outstations. Control operations are tightly regulated to ensure safety, determinism, prevention of unintended actuation. Controls are applied to binary output points and analog output points. 5.6 Select Before Operate BO Control Model. Rationale for SBO. The Select Before Operate model is the primary safety mechanism in DNP3 control operations. It prevents accidental or unauthorized actions by requiring a two-step sequence. Select operation. During the select phase, the master identifies a specific control point. The outstation validates availability and readiness. No physical action is performed. If accepted, the outstation temporarily reserves the control point. Operate operation during the operate phase. The master confirms intent to execute. The outstation performs the physical action. Success or failure status is returned. Operate requests must occur within a defined time window following selection. Control reservation and timeout. If the operate command is not received within the allowed window, the selection expires. The control point is released. No action is taken. This prevents stale or delayed commands from causing unsafe operations. TASH-HAV 5.7 Direct Operate Model. Direct operate without acknowledge. In this mode, a single command both selects and executes the control. No select phase is used. Execution occurs immediately. This model is suitable only for non-critical operations where safety risk is minimal. Cache Direct Operate with Acknowledge. This variation includes confirmation of execution, but still lacks a separate select phase. It provides feedback while maintaining lower latency than SBO. 5.8 Binary Output Controls. Binary outputs represent discrete actions, such as trip, close, start, stop. Binary output objects encode control code, latch on, latch off, pulse, count or duration parameters, status and execution flags. Pulse controls allow timed actuation without continuous assertion. 5.9 Analog Output Controls. Analog outputs are used to set continuous values, such as voltage set points, flow targets, pressure references. Analog output functions support multiple data representations, including integer and floating point formats. Execution semantics ensure that only valid ranges and authorized values are accepted. NAPSHAR 5.10 Freeze and Counter Management Functions. Freeze operations. Freeze functions allow the master to capture counter values at a specific moment, reset counters after capture, optional. This is commonly used for billing and energy accounting. Counter reset and management counters may increment continuously, roll over at defined limits, be reset explicitly under controlled conditions. Freeze operations preserve data consistency during reporting cycles. 5.1 Time synchronization functions. Accurate timestamps are critical for event analysis. DNP3 provides time synchronization functions that allow the master to write absolute time to the outstation, align event timestamps across devices, maintain sequence of events integrity. Time sync operations account for communication latency and processing delays. 5.5.1 Function execution flow. A typical DNP3 function execution follows this sequence. 1. Master constructs application request with function code. 2. Request is transmitted via transport and link layers. 3. Outstation validates request semantics. 4. Requested function is executed or rejected. 5. Response is generated with status information. 6. Master processes response and updates its database. Every step is explicitly defined to eliminate ambiguity. Taster 5.13 Determinism and safety in function design. DNP3 functions are deliberately constrained to avoid implicit actions, hidden side effects, undefined execution paths. Each function has a single, well-defined purpose, produces an explicit response, preserves system state integrity. This function model ensures that DNP3 control and data acquisition operations remain predictable, auditable, and safe in utility-grade environments.